Okay, so we're going to prove that a rational number times an irrational number is an irrational number. Okay, so first let's start with if we're given R is a rational number and R is not 0. This is given information. And X is irrational. Okay, we want to prove that R times X is irrational. Okay, so we're going to use the properties of fields, and we're going to use the fact that Q, the rational numbers, is a field. Okay, so if we're given this information here, if we're given all this information, R is a rational number, rationals are a field, then there exists some 1 over R, also because R is not 0, there exists a 1 over R such that R times 1 over R is 1. Okay? And then what we're going to do is we're going to say if R times X is rational. If R times X is rational, then we're going to use a property of the rational field again, that this, this 1 over R is a number that belongs to the rationals. That was a property of, that's one of the field axioms. Okay, so now we're going to use another property of the field axioms, that if this number right here is a rational number, if it belongs to that field, then we can multiply that by another number of that field, and the result, that product, will be a member of that field. So what we're going to do is we're going to take this number, which is, if this number was irrational, we'd be able to multiply it by this number, which is irrational. So then 1 over R times X will be rational, because this is, if we're assuming this is rational times another rational, the product is going to be rational. But the property is, another property is the commutative property, you can put R first and then 1 over R second, or 1 over R first and R second. Same thing, and that's going to be 1. So that implies, further implies, this is 1 times X belongs to the field of rationals. This implies that 1 times X belongs to the field of rationals. But this number 1 has a special property within a field, within the field of rationals, is that 1 times X equals X. So this all is saying, let's rewrite this out, except kind of skip this middle stuff. What we're saying is, if R times X is rational, that would imply that X has to be rational. But, so this is a true statement. But what's also a true statement, we're given all this information here is true, X is not rational. X is not rational. X is irrational. So we're also given that X is not rational. So by modus tollens, Rx is not rational, which means that Rx is irrational. Okay, so modus tollens. That's a recap of modus tollens as P implies Q, and then we're told not Q, and all that we can conclude not P. Not P.